let's discuss the ideas behind equilibrium. What is equilibrium? We talk about it in Gen Chem 1, but we also talk about it right after reaction rates. And what I find students sometimes happens to them is they start confusing the two, but they're completely different. So my hope in this video is to kind of tease some of those ideas, and think about it more than just equilibrium is the one with the forward and the backward arrow, whereas reaction rate is just a forward arrow in that balanced chemical equation. And so what is equilibrium? So I'm going to use this setup here. We have two tubs. One is empty and one is filled with water. And so reaction rate is the point at which your forward and reverse reaction are happening such that your ratio of products is relatively equal. Okay, doesn't mean there's the same number of products as there are reactants. That's not true at all. It's the ratio is constant. So your equilibrium constant is equal to your products divided by your reactants. Okay, so remembering all of that of the equilibrium expression. And so what's happening is I'm going to scoop up with both of my hands and I'm going to pour into the opposite bucket. And you can see that now the forward rate, so the rate going from this bucket here, you can think about this as your reactants, and this bucket here being your products. My forward rate, as I'm dumping, is greater than, because see, I'm getting like a tiny little bit in there, but I'm getting a lot in this one. And so my forward rate is greater than my reverse rate. And so that's how the reaction rates relate to equilibrium. Once I eventually get it equal, you're going to see my reverse rate is going to start speeding up just because I am filling up the tub more, and so I can scoop more. And so you can see that I'm putting more into my reactant bucket with every scoop. And so equilibrium is slowly being established. Now, in this case, my two cups are the same size, which means that my rates are essentially the same as forward and reverse rates. That's not always the case. And some reactions, the rate going forward is greater than the rate going backwards, which changes your equilibrium constant respectively. And so now you can kind of see I'm really close to having as I'm scooping the same amount up approximately each time. It's a little hard to see on the video, I know, but that's when equilibrium is reached. It's not when these two buckets are filled equally, okay? It's when the rates forward and reverse are the same, because I am pouring from a cup that's equal size, this rate is just staying the same, okay? And so rate is the point at which you're going from product to reactants or reactant to products, but equilibrium is when that ratio doesn't change, which means the amount in your buckets, that doesn't change. Not that they're equal, it's that the ratio is constant. And so that's really the concept of equilibrium, is getting to a point where there's totally stuff changing all the time, but the net system is consistent. All right, we're going to be looking at so much stuff relating to equilibrium. And so kind of having your idea within your brain of what is equilibrium, what does that mean, is vital. The concept of equilibrium also strongly pertains to that of solubility. Because remember, if you've got your reactant is a solid and you're going to product, which is aqueous, you can set up an equilibrium constant for that type of reaction. And so your solubility, how much of it dissolves when you put it into your substance, is going to depend upon that solubility constant, which is just an equilibrium expression. And so you're reaching a state at which, for that given temperature, pressure, conditions, it is a constant ratio. And so that's very important when we're talking about all the processes that we're going to be looking at in Quant this year. And so kind of remind yourself, what is equilibrium? We're going to get into it, I think, in chapter 6. We're going to get into it very much in depth, but kind of remind yourself of the basics right now.